In the previous video, we talked about the derivative of the natural log of the x, which is given by the 1 over x, and the derivative of the exponential functions a to the power x, which is given by the a power x ln a, here a in case being 2 and 5. So the general formula will be d over dx a power x is equal to a power x ln a. Today we are going to find the integrals of the 1 over x and the integral of the exponential function a power x. So let's get started. So as we know that the integration is the reverse process of the differentiation. The derivative of the x square is 2x and its integral is given by the x square in the reverse. We know that the derivative of the ln x is given by the 1 over x, which we calculated in the previous lectures. So in this case, we can conclude that the integral of 1 over x can be ln x and the plus of constant of integration. This is known as the standard formula of integration of 1 over x. And now let's calculate the integral of the exponential functions. We know that the derivative of a power x is equal to a power x ln a, and we can take that ln a, which is constant, on the other side of the equation. So the derivative of the a power x over ln a is equals to a power x. So the right side is the derivative of the a power x over ln a, and we can conclude that the integral of a power x can be a power x over ln a and the plus of constant of integration. This is also the standard formula of the integration of exponential functions. So now let's solve a practice problem and put it all together in the one function and calculate its integral. So the function is x square plus 3 over x minus 2 power x. So we know that the integral is a linear operator, and we can put the integral sign to the each term separately and solve for each term separately.